problem 80. This is problem 80. This is problem 83. This is problem 83 on 5.4, and another good example of a logarithmic and exponential functions, how they are inverse of one another, and graphing them and getting domain and range. So I'm starting out with my function e to the x plus 2 minus 3. And the first question asks me, what is the domain? Well, I don't have any variables in a denominator. I don't have any variables underneath a radical sign, so I don't need to worry about that. And I don't have any variables that are arguments of a logarithm, so I don't need to worry about that. So my domain is all real numbers, which isn't surprising. It's just an exponential function, and it just has to do with e. And e, as we know, is approximately 2.718. You know, I'm going to graph it kind of close to 3. And I'm going to start with my parent function, which would be e to the x. And I know that if it's an exponential function, I'm going to have 0, 1, 1e, and negative 1, 1 over e. Those are going to be the points that are going to guide me, and I know that my x-axis is going to be my horizontal asymptote. So I have the point 0, 1, 1e, which will graph right about there close to 3, and negative 1, about a third. And I'm going to draw my graph, an exponential parent function graph. It's going to look kind of like that. That's pretty good. Now I need to transform it. So I know I'm going to have to move to the left 2 and down 3. Well, if I'm moving down 3, I'm going to start off by moving my horizontal asymptote down 3. So I'm going to go here to negative 3. It was at 0. It's now at negative 3. Oh, and I've already got dotted lines nicely set up. So my horizontal asymptote is now drawn in. And now all I need to do is move my points to the left 2 and then down 3. So let's do that. Let's make it a different color. This point here to the left 2, down 3. It's very close to the asymptote. This point here, which was my 0 point, to the left 2, down 1, 2, 3, right there. So I already know that that point was 0, 1, and now it's going to be negative 2, negative 2. So that point I'm going to label negative 2, negative 2. And this point here, I'm going to move it to the left 2, down 3. So that point right there is going to be at negative 1, 0. Is that right? No, that isn't right. It's not negative 1, 0. You guys get confused about e. It bothers me as well. I know it's at negative 1, and since I'm down 3, it should be a little bit below the x-axis, because it was at 2.718 and now it's like a tiny bit below. So I'm not going to calculate what it is, but my graph is going to look right about like that. So that is the graph of my transformed function, and it's asking me, saying, from the graph, determine the range and any asymptotes of this function. Well, we know we have a horizontal asymptote here at negative 3, so my range is going to go from negative 3 to infinity. The next thing they want me to do is they want me to calculate the inverse, and I need to do that algebraically. So I'm going to change my f of x to y. So y equals e to the x plus 2 minus 3. And now I'm going to switch my x's and y's. So x is equal to e to the y plus 2 minus 3. Now I need to solve for y. Well, y is trapped up here as an exponent. So if I have something that's trapped as an exponent and I want to free it, I take the log. Just like if I have something that's trapped under a radical sign, if I want to free it up out of the radical sign, I square it. I do the inverse operation. Well, The inverse operation of an exponent is a logarithm. So I'm going to end up taking the logarithm of this side of the equation to free up my y. But before I do that, I have to get rid of this 3. I can't have this little, this kind of debris hanging around here, so I'm going to go plus 3, so I get x plus 3 is equal to e to the y plus 2. Well, now if I take a logarithm of both sides, that is going to free up my y as an exponent. So what I'm going to do is I'll write it out just so that you can see it. I'm going to go ln, because that is log base e. So ln x plus 3. Let's not write it as an exponent. Let's write it properly. So ln, I'm taking the logarithm on the left side, x plus 3, and I must use parentheses to make sure it's clear that the x plus 3 is the argument of my logarithm, is equal to ln e to the y plus 2. Well, I'm going to write my little base in here. So this expression right here is asking me a question. It's saying, what exponent do I have to put on base e in order to get e to the y plus 2? Well, this is why it frees up this is why it frees up my variable, because the exponent I need to put on e to get e to the y plus 2 is y plus 2. So I get y plus 2 is equal to ln x plus 3. Now I'm almost done freeing my y up here. I'm going to subtract 2 from both sides. So I get ln x plus 3 minus 2 is equal to y. And in order to make this perfectly right, I'm going to go f minus 1 of x. The inverse of my function is ln x plus 3 minus 2. Well, now that we've got the inverse of the function, let's try graphing it. So our parent function is ln x. So we have y equals ln x, and we know that the base of ln is e. So I'm going to move my e over to the other side. I'm going to bump up my exponent, so I'm going to have e to the y is equal to x. And I'll set up my little chart here. X, y. Yeah, I'll make this better looking, x. And it's easier, again, to graph these logarithmic functions by putting them into exponential form and then starting with y. So I'll use my values of y that I like. When y is 0, x is 1. When y is negative 1, x is 1 over e. And when x is 1, when y is 1, x is e. You can see that those are the inverse of the points that we had in our original function right here, 0, 1, 1e, and negative 1, 1 over e. Now, we've reversed them. So let's graph that. So x is 1, y is 0. X is 1 over e, so that's about 1/3. Y is negative 1. X is e, so about, close to 3, almost 3. Y is 1. So I can see that our logarithmic graph is going to look like something like that. I have to transform it. So I have to transform it left 3 and, now I can't see, hold on. That's left 3 and down 2. This is a minus sign right there. It looks like a dot. Sorry. So if I'm going to go left 3, the first thing I'm going to do is I'm going to move my vertical asymptote over 3. So let's get a nice line here. My vertical asymptote, which is now the y-axis, is now going to be negative 3. There's a nice dotted line for vertical asymptote. And then down 2. So let's go each point. Let's get it to, we want to be a pen. Come on, pens. There we go. Left 3, this is the one that's very close to my asymptote. Down 2, right there. Left 3, down 2, right there. Left 3, down 2, right there. And my transformed graph looks like something like that. Looking at the graph, I would say that my domain is negative 3 to infinity. I would say that my range is negative infinity to infinity. How does that compare with my original graph? It's the inverse, just as we suspected. If I put those two on the same graph paper, it's kind of hard to do, so I'm not going to do that. But you would see that they reflect one another over the line y equals x.